We're in Algebra 2 lesson, or Algebra 1, sorry, lesson 9-2. Today's date is January 30th. Did I update it? Whew, I did update it. I always get nervous in the first class. 1/30. All right, so make sure your name, make sure your date are on the paper. I should be seeing you writing. Gunner, be writing. All right, so let's talk about what our previous way of solving was. Previously, we did graphing, right? The problem with that is as follows. So let's say I have these two equations, 2x plus 1, negative 3 over 2x minus 2, and it's in slope-intercept form. I did that graphing for you, so you don't need a ruler today. All right. I forgot to, Sergio, can you pass these out for me? I forgot to pass out participation cards. All right, so quiet raised hand. What is the solution to this problem? Where do they intersect? Or does someone want to say maybe what the problem is? Either tell me what the answer is or what is the problem with graphing. I should see hopefully about 3 hands for this. What is the problem when I graph? Why is this hard now? Or just tell me what the answer is. Fernando, I see a quiet raised hand. Go for it.
Because it's not like on an interest or like slope interest. It's not a whole number.
It's not a whole number. Yeah, this is probably negative 1.6 or 8 for the x-coordinate, and the y-coordinate is maybe 1.6 or 5. I don't know what it is. It's not a whole number. It's not a lattice point, right?
No, it's not a lattice point.
It is not a lattice point. And if you like that word and you want to use that word over and over, write it on off to the side. Lattice point.
Lattice point equals.
That just means it's a whole number. Whole number. You can start using that term over and over. I never even heard of the term lattice point until I was in college. And it's a really important concept because if it lands on a lattice point, it's really, really nice. What was that for me? Thank you. All right, so it's not on a lattice point. So graphing in equations is not good at solving this system of equations when it's not a lattice point. When it's not a lattice point. Or when, I guess what I really mean is the answer. So maybe answer is a better word. When the answer, I don't know why there's 2 R's there. When the answer is not a lattice point. But how do you know when it's not a lattice point? You have to solve it and you're like, oh shoot, I spent all that work graphing it and it's not a lattice point. Dang it, what am I going to do now? And here's the answer. And it's answered with a puzzle. So this is a puzzle for you guys. We're going to break out into groups here. Can you figure out how much x or y, either one of them weighs? If you can solve for both of them, man, you are an A plus solver. Not a student, but an A plus solver. It's a really hard question. So we have these 2 scales. We know that if I weigh x, and y, those weigh 8. We could say 8 kilograms if we want to have some units. And if I have x and y, they weigh 5 kilograms. How do I figure out how much x and y weigh? I'm going to give you guys 5 minutes to try to solve this on your own. How can you use these 2 facts to solve this puzzle? How much do x and y weigh? All right, so go ahead and break out. Do it on your own. Do it within your groups. You can do it within the whole class. You can ask Ms. Laura. You can ask Mr. Sindel. How are you going to solve this puzzle? Go ahead and do that now. So we're back. Most people have an answer, and a few of those people are able to explain their answer. Who wants to explain their answer? We'll give it to Gunner. You can get up to the board if you want. Yeah, it's all yours.
So extra.
What's that mark?
Take half of it. There's 5 here. And they added 3. And also this. You graph this. Take away the 3. That means x would have to be 3. So, and then, so we got x equals 3. So we take this out, and that's 2. That's y. So y is 2.
All right.
But y. Y. It's y.
Can you re-explain, Gunner, to me and to the class? How did you get x equals 3 again?
Oh. So I saw that they added 3 to this. Here. We have 8. There's 5 here. And I took away 3 from that, and I also took away this. So that's the answer would be 3.
Ah, I see. So you're saying that The only thing that changed between the scale on the left and the scale on the right was the left-hand side for the left scale, you added an x and you also added 3. So therefore x must be 3. You're adding the same thing both sides. Okay, yeah. And then from there you just solve for y equals 2. You have a question, Andres?
I kind of had the different.
A different way? Okay, yeah, go for it. Gunnar, can I have your card? Go for it, Andres.
We have to go up.
Yeah.
Like,
Let me do that. All right.
okay. So x has to have like the same amount of ones there. So wait. Yeah. So you can't have 4 for x because then y will equal 0. So it would have to be 3 because they both like have 3 of ones, and then the leftover could be y. And then if you plug them in, x equals 3, and then y equals 2. Yeah, y equals 2.
Ah, so you're assuming that x and y are both whole numbers.
Yes.
What if x was 1.5? Then 2x would be 3. That would kind of punch a hole in your theory, though. Okay, but that's really good. You ended up doing making an assumption that happened to be correct, and you got the correct answer. Yeah, thank you. Turn your card, Andres. All right, so let's talk about the procedure in terms of what's happening with the algebra. In terms of the algebra, I noticed that the only difference between these two scales is that an x is being added and an x should be added here. If I'm adding an x to this right-hand scale, then I also need to add 3 more to have it the same as the left-hand scale. So that means I'm adding an x and I'm adding 3 of these 1 blocks. This is essentially Gunnar's argument. In terms of the algebra, what's happening here is I can do the reverse of that, which is I can subtract this x and y and 5. If I come back here and do the opposite of what Gunnar just said, if I subtract 5 and subtract 5, 1, 2, 3, 4, 5, I subtracted 5 from the right-hand side, and I'm also going to subtract an x and a y. Subtract an x and a y, subtract an x and a y. I know that the left and the right were balanced for the right-hand scale, and I know that the left and the right are still balanced because I've taken away a balanced amount. I've taken away an x and a y on the left, I've taken away 5 on the right, therefore what's left over is an x and a 3. It's kind of the reverse of what Gunnar said, but it's still accurate. X is 3 because I've taken away the same amount. The way that we say that in terms of math is we say, oh, I see that these y's, if I just take this y, the second y away from the first y, I'll be left with no y's. In fact, I've eliminated the y's. Again, today's title is you're solving this using elimination. Elimination is just a way of saying eliminate one of the variables first to solve for the other variable. So what we're going to do, and this is what you're going to write, pick up your pencils. We're going to say subtract an x, subtract a y, subtract this 5. We're subtracting all of this equation from our first equation. So 2x minus x, shout it out. 1x, or just x. Y minus y is, shout it out. 0. Yeah, y minus y is just 0. So x plus 0 is equal to 8 minus 5 is 3. Therefore, x is 3. That's half of it. And then now I need to go back in and plug it into either of these two equations. And that's a really key point. I can plug x equals 3 into the first equation, or I could plug x equals 3 into the second equation. This second equation is a little bit easier, assuming there's no minuses. So I'm going to write now 3, I'm plugging in for this x, and I'm going to rewrite the rest of the equation. 3 plus y is equal to 5. I'm rewriting the second equation, but in the place of x, I'm writing a 3 because x is 3. So 3 plus y is equal to 5, and I'm going to do what to both sides? Quiet raised hand to solve for y. Easy XP here. What am I going to do to both sides to solve for y? Jose? Minus 3 on both sides. So therefore, y is equal to, there it is. Thank you. You can turn in your card. Question, go for it.
Can you subtract it?
Yes. So Sergio is asking an amazing question. Can I subtract the first equation instead of doing the second equation? So let's assume that these were all positive. If I subtract, 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 you're still going to be canceling out the y's because it's going to be a positive y minus a y, you're still going to be eliminating a y. Yeah, you could have subtracted the first equation, or you could have subtracted the second equation. Either way would have worked. Oh, thank you. Jose, yeah.
I noticed that there's like, on those scales, there's 3 x's and 2 y's. You just count math and skip that.
It happened to be 3 x's and 2 y's. I think Julian also pointed that out as well. That is a coincidence. That's not how it actually happens. You can't always say, oh, I just counted up 7 x's, so the answer is x equals 7. Yeah, just a coincidence. So let's solve this system of equations, for example 1, without using any scales. It's a little bit harder now that it's there's more things happening. This one is pretty straightforward and it's very like the homework on Khan Academy. I need to eliminate one of the variables. I'm allowed to add or subtract these 2 equations. What should we do? Should we add or should we subtract? I need a quiet raised hand. Give me the strategy so that I eliminate one of the variables. I'm looking for someone that still has their card. Should I add or subtract these guys? Sergio. Subtract. What do you mean?
Just subtract 4x and 2y and 4.
So you're subtracting like this. So negative 2y minus 2y is negative 4y, like that. 3x minus 4x is negative x. Uh-oh. There's a problem. I haven't eliminated x or y. So it's not subtracting. Do you see what you should be doing?
You add?
You just add, yeah. Yeah, so if I add each of these, if I'm adding, that means 3x plus 4x is what, Sergio? 7x. Negative 2y plus 2y is, there's the key. I'm not even going to do the right-hand side right now. I need to make sure that I have eliminated one of the variables, otherwise I'm not doing elimination, this whole process of elimination. Elimination is just adding and subtracting these 2 equations. So thank you, Sergio. You can turn in your card if you haven't done so already. All right, so 7x plus 0 is equal to 10 plus 4, which is 14. What am I going to do to both sides? Quiet raised hand. What am I going to do to both sides to solve for x, Monse? Divide by 7, divide by 7. Therefore, Monse, x is equal to? X is equal to 2. There's half of our answer. So thank you, Monse. You can turn in your card. What am I going to do now? I have half of it, but I need x and y. Again, I need an x and a y coordinate because what's really happening here on the graphs is there's some intersection where that point of intersection is an x and y coordinate. I need the y coordinate of that intersection now. How do I find that y coordinate? What do I do with this information? I do something with this x equals 2. Jenny. Yeah, which one do you want to do? You can choose either one, whichever one looks easy to you. The second one. Why'd you choose the second one? Just random?
Yeah.
Yep, that's totally fine. I like the second one more too because it doesn't have a minus. I don't like minuses as much because I make mistakes all the time. So let's plug it into the second one. I'm going to rewrite the second equation, but instead of writing an x, I'm going to write a 2. Do it with Mr. Sindel. Here we go. 4 times, oh, there's my x. It's a 2 now. 4 times x, I'm rewriting the second equation. Come on, computer, you can keep up with me. And then plus 2y is equal to 4. I'm rewriting that second equation, but in the place of x, it's a 2. I'm substituting x equals 2 into the second equation. Okay, my next step, quiet raised hand. What am I going to do? I need to simplify. Josie. Yeah, you want to go for it? Go for it, yeah.
8.
Yep. 8, read the rest of the equation to me. There it is. Yeah, good job. Thank you, Josie. You can turn in your card. What do I do now? Next step. People that still have their card. You don't have your card anymore. All right, I'm looking at Andres. No, Andres, you have your card in. I'm looking at maybe Jessica, Fernando. Do you have your card still? Yeah. Or Julian, I think. There's 3 people still. Yeah, Jessica, go for it.
Oh, would you subtract 8 on both sides?
You do indeed subtract 8 on both sides. Yeah, because we're trying to isolate that y. So that'll cancel out the 8. That'll cancel out. And what's 4 minus 8, Jessica? Negative 4. And that's equal to what's on the left-hand side now, Jessica? 2y. Yeah, thank you, Jessica. All right, and my final step here. Yeah, Julian?
Divide by 2.
On both sides. So therefore, y is equal to?
Negative 2.
Negative 2. There it is. We need both of those. Those are our answers. X equals 2, y equals -2. Thank you, Julie. There's only one person I believe that has not participated, I think. Is that correct? Just Fernando? All right. All right. Fernando, tell me what to do. We're on example 2. We're on the back.
Plus 5y, or just add
Add them. Okay, so 5y minus 5y, I add those and I get
0.
-3x and 2x. I add them and I get
6.
I add.
Oh shoot, 5x.
Careful, it's a negative and a positive.
Oh, I thought you were adding.
Yep, I'm adding. I'm adding this.
Okay. 1. Oh, just x.
Just x. Careful, there's a tiny error there.
Negative x.
There it is, -x. And again, finally, I'm putting you on the spot again, Fernando. 7 and -8, add 2. -1, there it is. Everyone copy it down. 0 and -x and -1. We just added straight down. If you want to do a little plus with your line to let you remember that we're just adding straight through. Thank you, Fernando. All right, everyone should have their cards in, is that correct? And I should be marking that the people that are absent today, Cohen and Eder. All right. My next step, I haven't solved for x, I've solved for -x. So how do I get rid of this negative? Everyone can participate as many times as they want now. What am I going to do to both sides? Sergio.
Times -1.
Yeah, times by -1, times -1, times -1. As long as you multiply the left and right by the same amount, you're preserving that balance from that scale that we saw in the very beginning. -1 times -x, Sergio, is 1x, yeah, or just x. So the negative times the negative is a positive, and Sergio on the right, -1 times -1 is a 1, yeah. So x equals 1. That's my first step. Thank you, Sergio. That's my first step. X equals 1. I have half of the answer. I need x and y, so what am I going to do? Quiet raise hand. What is my next step? 2 people know. I'm waiting for 4 hands. 2 people know. 3 people know. Okay, 3 people know. I'm waiting for one more hand. There it is. We'll give it to Jenny.
Plug in 1.
Yeah, we gave this to you last time, didn't we? You do plug in 1. I'll give you the XP. Jose, which equation do you want to plug it into?
The second one.
The second one. Why'd you choose the second one? Randomly? Okay, let's do it. Jose, read me the equation after x is plugged in, after x is substituted in.
-5y
Plus 2 times 1 equals -8. Yep, everyone copy it down. We just rewrote that second equation. Again, it's random. It doesn't matter if it's the first or the second. Both will get the same answer. I'm plugging it in, and yeah, there it is. Jose, XP, done. Next step, what am I going to do? Andres, go for it. I'm going to make you do 2 steps, Andres. 2 times 1.
Wait, can I just do the whole thing?
Sure.
Okay, so 2, and then...
That's 2.
Yeah. And it's going to be -5y.
Yep, -5y plus 2 is equal to -8, right?
Yeah.
What am I going to do after that?
You subtract 2 to both sides.
Yep.
2 to 8.
So there's my 2. I'm going to subtract 2, chunk, chunk. That 2 cancels out. And what is -8 minus 2? -10. What's on the left-hand side, Andres?
-5.
-5y. Good job. All right. Boom. All right. And finally, we'll give someone else some XP. What is my final step to get y by itself? 1 person knows, 2 people know, 3 people know, 4 people know. Gunner.
Divide 5.
Divide by...
5.
Careful.
Wait. -5.
-5. Yes. So divide -5 on both sides. And what is y then, Gunner?
Y. Wait.
Yeah, it is just y on the left.
Equals 2.
Y equals 2. There it is. If you have them separate like this and they're not in the same spot, just go ahead and box each of them. Technically, they're both part of the answer. X equals 1, y equals 2. And notice that there were a total of 5 x's, and yeah, I guess it doesn't match like our first equation, our first example. X equals 1, y equals 2. Okay. This is the part where I'm going to lose a lot of people. So this is the first homework assignment. Example 1 and example 2 are like the first homework assignment. Almost every single time you're just going to add them and solve. This is where it gets really hard. And I know I'm going to lose you, so pay the most attention right now. Here we go. We have a problem. No matter what I do, if I add or subtract, I will not be able to eliminate a variable with our laser focus. You can see, if I add these, I'm going to get negative x. If I add these, I'm going to get just y. If I subtract them, there's no way to eliminate a variable. Here's the trick. You already see the trick, Sergio? What's the trick, Sergio?
Multiply.
Yeah, which one do you want to multiply?
Top.
By?
2.
Yep, okay, so here's your trick. This entire equation, I'm going to multiply by 2. Which is the same thing as multiplying by the left and the right by 2. Yeah, good job, Sergio. Have you seen this before, Sergio?
No.
You just can see it? That's awesome, yeah. So Sergio. So if I multiply the left and the right by 2, which is the same thing as saying multiply every single term by 2, then you'll see that I'm going to have a 2x and a negative 2x. This is like playing chess. You're seeing multiple moves ahead. If I multiply everything by 2, then I can add them straight down. 2x and negative 2x will be eliminated because 2x minus 2x is 0. By multiplying the top equation by 2 and then by adding them, I have eliminated a variable. This is the hardest part of today's lesson. Do we see why we wanted to multiply by 2 and how that would eliminate the variable? It's okay if you nod your head no. I'll be able to tell. Everyone nod your head either yes or no. Okay. So when I do that, I'm going to rewrite this equation underneath. I'm going to rewrite this. This is now going to say 2x. 2 times 2y is 4y. I'm multiplying every single term here by 2. So 2 times 2y is 4y. 2 times 10 is 20. Now, with these two equations right here, I can add them and eliminate the variable. This is where you guys come into play, and you're just doing the same thing that we did last time. Add them straight down. Quiet raised hand. Who's going to do that for us? Who's going to add each of these columns? Jose, go for it.
Okay, so 0
0
plus 3y equals 16.
16. Yep. Okay. I realize that this is a nasty problem because we're going to get a bad number. Can we change this 4 to a negative 5? Sorry about that, guys. Let's change that to a negative 5. So, Jose, if I change that to a negative 5, what's negative 5 plus 20? Okay, this is Mr. Sindel making a change to what the notes should have been. This is not a math move. I'm just changing it to make it a nice problem. 15. All right, thank you. And then, Jose, what am I going to do next?
Divide by 3 on both sides.
Yep, divide by 3 on both sides. To get y equals 5. Thank you, Jose. So that is half of the answer. That is half of the answer. How do I get the second half of the answer? Same move as before. We have 3 equations technically now. I guess this is just really the first equation. This is the first equation multiplied by 2. But any of these 3 equations you can substitute into. Whatever is easiest for you. What are we going to do? Only Sergio's going to do it. Jenny knows this step pretty well. She's done it before. Fernando, tell us what to do. Plug in 5 to which equation?
First.
All right, so tell me what to write.
X plus 2 times 5.
2 times that 5 down below equals 10. Yeah, this 5 is being plugged into our equation. All right, this is going to be pretty straightforward. One last volunteer to solve this one for us. You're going to be multiplying and doing things. Andres, go for it.
2 times 5 is 10.
Yep, so it's going to be x plus 10 is equal to
10.
10. And then I'm going to do what?
Minus 10 on both sides.
Minus 10 on both sides to get
0.
x is equal to, yeah, that technically cancels out too, 0. And box it. It happens. X can be 0, y is equal to 5. The second half of the homework is being able to do this on your own. Being able to say, okay, what should I multiply one of these equations by? Here is the hardest type of question, which unfortunately is on the homework. This one. This is the hardest type of question I can ever ask you with elimination. This one is hard because you need to multiply the top equation and the bottom equation by a number.
It has to be the same.
And they have to have some term that will cancel each other out. Is there any way to multiply the top and bottom by two different numbers, or it could be the same number, probably two different numbers though, such that I will be able to eliminate a variable? This is, again, the hardest step. This is going to need the laser focus. What can I multiply the top and bottom equation by such that I eliminate a variable? Wow, people are already getting it.
We have a question.
Oh, question, yes.
I said
Do they have you have to multiply by the same number?
No, they can be different numbers. I can say multiply the whole top equation by 5, multiply the whole bottom equation by 2. It doesn't matter if the top and bottom are the same or not. They, in fact, should be different. You can choose any number that will automatically eliminate the variable. Yeah, that's the hard part, figuring out. All right, Fernando, talk to me.
Multiply the top by 5 and the bottom by 8.
Yep, you're right. I'm going to pause right there and let everyone else see that. If I multiply the top by 5 and the bottom by 8, everyone else, which variable is Fernando trying to eliminate? Is he trying to eliminate the y's or the x's right now? If you know, don't shout it out. Thank you, Andres. It is the y. But why? Why is the y being eliminated by multiplying that out? So, in order to see this, I'm going to actually carry out Fernando's operation. Fernando said, hey, multiply the top by 5. I'm going to multiply 8y by 5. 8 times 5 is 40y. 5 times negative 9 is, shout it out, negative 45. And I also have to multiply the negative 3 by 5. Every single term here gets multiplied by 5. So negative 3 times 5 is negative 15, right? Yeah. So we are really distributing that 5 into each of these terms. Okay, now I'm going to do the next one. I'm going to multiply 8 by each of these terms. 8 times 5 is, hey, look at that. We have the same term. That means we can cancel them out. In fact, here's an even cool trick that I can do. I'm going to change Fernando's method slightly. I'm going to make this a negative 8. If we distribute a negative 8, then instead of having to subtract, we can just add. So if I distribute a negative 8, now it's a negative 40. Look at this. I can just add these straight down and they will eliminate the y's. What's a negative 8 times a negative 8? Positive 64x. And I'm going to have to say negative 8 times 10 is a negative 80. There it is. So the general strategy is, if you have to multiply by 2, you can't see anything that you just multiply by 1, multiply by the opposite number. Notice how there's this cool little diagonal. These 5s match up, these 8s match up. Go ahead and mark that in your notes. The diagonals are really what you want to multiply by. I could have multiplied by 8 and 9. That would have also worked because those are diagonals for these numbers. I could have eliminated the x's first. Again, this is the hardest part of the lesson. I know it is. Really try to get this. Spend the time to understand. Why did we multiply by 5? Why did we multiply by negative 8? We wanted to eliminate the variable. We got the same coefficient in front of the y, the same number in front of the y. Therefore, they're able to cancel each other out. So from there, we're going to go, I'm going to do this really quick so we can move on to the homework for at least a few minutes. 40y and 40y, they're going to cancel each other out, and I'm just left with 64 minus 45. That is 19. X is equal to, this is going to be negative 95. I'm just adding them straight down. And let me just double check, 64 minus 45. I don't want to make a mistake. Good. And now I need to divide both sides by 19. Divide by 19, divide by 19. This is just the algebra. 95 divided by 19 is 5. So x is equal to 5. X is equal to 5. Because 95 divided by 19, ooh, negative 5. Sorry about that. X is equal to negative 5. That's half the answer. And just like before, I can plug that into either of these equations. I'm just going to randomly choose, again, the second equation. I'm going to read the second equation, but in the place of an x, in place of this x, I'm going to put a negative 5. This is all review now from the previous notes. 5y minus 8. Oh, there's my x. My x should be negative 5 is equal to 10. From there, I'm going to simplify. Negative 8 times 5, that's a negative 40, or sorry, positive 40, because a negative times a negative. And I still have this 5y plus 40 is equal to 10. I'm going to now subtract 40 from both sides. I know I'm going way too fast, but I do want to get through this. Those cancel out. I'm left with negative 30. On the left-hand side, I still have this 5y. And finally, I'm going to divide both sides by 5, divide both sides by 5, and I get y is equal to negative 6. The hardest part was figuring out what numbers to multiply to eliminate the variable. And this, again, is called elimination. This is the method of elimination, where you eliminate the variable by figuring out what to multiply the top and bottom by. All right. I'm hoping that, on average, all of us on the second homework assignment can get 50%. These are hard. I'm hoping to get 50%. That's my goal. If you can get above 50%, you have hit that goal. All right. Go ahead and write your summaries now.